Good morning, Year 6. We are going to be learning all about circuits and electricity this term in science. And today, more specifically, we are going to be learning about static electricity, and we're going to understand why our hair does this when we rub balloons against it. We've got lots of exciting experiments planned today, so let's get started. I'm going to share my PowerPoint presentation with you so you can see it. So in today's lesson, you are going to need an exercise book or paper. This printout, if you have it, if you don't have a printer, absolutely fine. We can just write it down on your piece of paper, a pen or pencil, and if you have it, a balloon, absolutely no worries. If you don't have one, next time you come across a balloon, whenever or wherever it may be, you can do the experiments that I'm going to show you today and remember how they're done. So let's start off with the knowledge quiz, as always. So I'd like you to get your pen and paper out and write down your answers. You don't need to write out the whole sentence, just your answers, and then we'll go through the answers together. Question 1. The respiratory system is how we get bleep in and bleep out of our bodies. When I say bleep, that means blank, and that means you have to write the answer. So I'm going to repeat the question. The respiratory system is how we get beep in and beep out of our bodies. I'm going to pause. Please pause the video here and write down your answer. Little tip, there are 2 types of gases. Question 2, what is the name of the broom-like hairs in the lungs? What is the name of the broom-like hairs in the lungs? Pause the video and write down your answer. Question 3. When blood cells are holding oxygen, they are known as being what? When blood cells are holding oxygen, they are known as being what? Pause the video and write down your answer. Question 4. Where does the right ventricle pump blood to? A, the left ventricle, B, the lungs, or C, the rest of the body? Little clue, when we're studying the lungs, your left and right is the opposite to what it normally is on your hands. I'll repeat the question. Question 4, where does the right ventricle pump blood to? Is A, the left ventricle, B, the lungs, or C, the rest of the body? If you need another clue, remember that the top 2 chambers of the heart are both the right and left atriums, because A comes before V in the alphabet, and the bottom 2 chambers of the heart are called the left and right ventricles, because V comes at the end of the alphabet. It's a way to remember it. So pause the video and write down your answer to question 4. Final question in the knowledge quiz. Who proposed the theory of gravity? A, Sir Isaac Newton, B, Charles Darwin, C, Benjamin Franklin? Repeat the question. Who proposed the theory of gravity? Not evolution, gravity. A, Sir Isaac Newton, B, Charles Darwin, or C, Benjamin Franklin? Pause the video and write down your answer. Let's go through the answers together. Question 1, the respiratory system is how we get oxygen in and carbon dioxide out of our bodies. Remember, we all need oxygen in order to breathe, in order to respire. It's how we get energy. So we want oxygen in and carbon dioxide out. What is the name of the broom-like hairs in the lungs? They're called cilia. Remember, we studied these when we learned about smoking and the effects of it on your body. Cilia helps sweep mucus out of your lungs. So, question 3. When blood cells are holding oxygen, they are known as being oxygenated. Clues in the name. Oxygenated means holding oxygen. Question 4. Where does the right ventricle pump blood to? The right ventricle pumps blood to the lungs. Final question. Who proposed the theory of gravity? That was Sir Isaac Newton. The famous anecdote is that the idea came to him when he was sitting under an apple tree and an apple hit him on the head. Slightly probably embellished story, but it's a nice story. And remember, Charles Darwin proposed the theory of evolution, not of gravity. And Benjamin Franklin is an American statesman who worked a lot on electricity and static charges, which we're going to learn more about today. So, moving on to static charges and electricity. Have you ever had a static shock when you have been on a trampoline and you touch a metal doorknob and you get a little zap of electricity? And what did it feel like? Did it feel like a little bit of electricity going through your body? You sometimes get a static shock of electricity when you take clothes out of a tumble dryer too. I wonder why that might be, and the clue is it has something to do with friction building up inside the tumble dryer. When the clothes are all rubbing together, something happens to the charge there. So let's learn a few key words. I know we're not together, but it'd be nice if you could repeat after me. Positive and negative. So we all know what this means in numbers and maths because we've studied negative and positive numbers. We know that negative numbers are below 0 and positive numbers are above 0. We also come across things in science called positive and negative charges, which we're going to learn more about today. So, next two words we would like to learn about are attract and repel. So when two things attract to each other, they move towards each other like this magnet here. It's a little fridge magnet of a panda on it. Oh, let me come out of screen share mode so I'm a bit larger. Yes, I think I should be large now. So you can see that these two objects attract to each other because this is a metal lid and this is a magnet. Two things attract to each other when their charges are not the same. So positive and negative things attract to each other. The other word here, repel, is when two things are forced to move away from each other. So like charges repel from each other. So two negative charges will push away from each other and two positive charges will push away from each other. I'm going to go back to screen share. Next two words, balanced and unbalanced. So when two things are balanced, for example, if you have 3 fingers on one hand and 3 fingers on the other hand, they are balanced, they are equal. If things are unbalanced, like on a seesaw, when one side is heavier than the other, things are unbalanced. And you can think of charges of being unbalanced too, when one object has a heavy negative charge and another object has a heavy positive charge. So let's see how these words apply in the science theory that we're going to learn about today. What is an atom? Atoms are the building blocks for everything around us. Everywhere you look is made up of objects which are made up of atoms. They are extremely small, the smallest things in the universe, even smaller than cells. In the center of the atom, there is a nucleus, as we see labeled here. This thing, blue and red thing in the middle is the nucleus. Now, moving on to the next slide, let's learn about electrons. electrons spin around the outside of the nucleus. You see a green electron here. They're spinning round and round and round the nucleus. This whole thing is called an atom. Now, it's important to know that electrons are negatively charged. Remember that electrons are negatively charged. So we see the green electrons here have a little minus sign on them. Why? Because they are negatively charged. Now, friction. I'm going to put all of these pieces of information together in a moment, but it's important to learn about them first. So friction, we know about friction. Objects rubbing together knock electrons loose. Some objects lose electrons whilst others pick them up. The gaining of electrons creates an electrical charge. The more electrons, the greater the negative electric charge. Charge becomes unbalanced when a balloon is rubbed against your hair, and different materials have different static charges. So let's put all of this information into practice. I'm going to rub this balloon against my hair, and I'm also going to rub this balloon against my hair and create friction. So we create friction when we rub two objects against each other. As I'm doing this, the negative electrons are transferring onto the balloons, and the balloons are becoming negatively charged. So let's see what happens when I lift them off. Let me come out of screen sharing mode so you can see it on the big screen. And you can see my hair is standing up. So the balloon is negatively charged and my hair is positively charged. And so my hair is attracting to the balloon. Crazy scientist hair here. What's also interesting to see is that since both balloons are negatively charged, as I push the yellow balloon close to the blue balloon, they're repelling from each other. And why are they repelling from each other? Because they are both negatively charged. And when two objects have the same charge, they repel. Now, let me go back to screen sharing and ask yourself these questions. What did you do, or what did I do? If you were doing this at home, you can ask yourself this. What happened and why did it happen? I'm also going to show you another experiment, but this time, instead of putting the balloon against another balloon, going to show you what happens with these pieces of paper. This is actually my favorite balloon experiment because I've rubbed the balloon against my hair, all the negative electrons have transferred onto the balloon, and as I move the balloon close to the piece of paper, you can see they're all being attracted to the balloon. And what does this tell us about the charge on the balloon? And what does it tell us about the charge on the pieces of paper? It tells us that they are different because they attract. The charge on the balloon is negative and the charge on the pieces of paper is positive, and that's why they attract, just like the magnet that I showed you at the beginning. One is positive and one is negative, and that's why they attract. So I would like you to please complete this worksheet either on your computers or print it out if you can, or you can just write up the answers on a piece of paper if that's easiest for you. So I would like you to use this vocab for completion. to fill in the blanks, and I would also like you to label this diagram. I'd like you to label the balloon, and I'd like you to label the sweater either with a plus or a minus to indicate which one you think is negative and which one you think is positive, and then we'll go through the answers together. So please pause this video now and complete the answers. Okay, now I would like you to mark your answers either with a pen or a pink highlighter. Let's go through the answers together. Both the balloon and the sweater are made up of atoms. As I said at the beginning, atoms make up all of the objects in the world. Rotating the nucleus of an atom are electrons. Remember the green negative circle I showed you at the beginning are the electrons rotating around the nucleus, i.e. the center of the atom. When you rub the balloon and the sweater together, it creates friction. We know that when we rub two things together, we create friction. This transfers electrons from the sweater to the balloon. The balloon becomes negatively charged and the sweater becomes positively charged. So now that we've completed that, we should be able to label our diagram. So have little negative signs on the balloon indicating the negative charge there. The imbalance we can see between the sweater and the balloon, and the positive charge on the sweater indicated and represented by the plus signs. Finally, let's learn a little bit about how electricity is discharged. And the most famous example of this in nature is lightning, which is very dramatic. Charge builds up when two materials are rubbed together, for example, socks on trampoline or balloon on hair. But on a larger scale, it happens in lightning when air particles rub together to create a static charge. So static charge is when there is an imbalance of positive and negative charge. When the imbalance becomes so great that it's no longer able to hold, that imbalance is balanced out by discharge of the two charges, and that is done by lightning. And the lightning discharges the positive and the negative charge. So thank you, Year 6, for listening to today's science. I hope you've learned something and find it interesting. And next time you're around a balloon, you can do some of these experiments yourself, either with pieces of paper or just with your hair, or try and doing it with by hanging up another balloon like that. Have a great day. Thanks, Year 6.